This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support.
Hybrid Cloud Show, episode 41. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So today I want to talk to you guys about tech debt. So I want to know what examples of tech debt you've seen, or if you're going to be honest to everybody, you can tell me about the tech debt that you yourself have put into place.
I've never done that, Aaron. That's only other people.
I mean, I'm going to start with a super common one. Instance types are the biggest piece of technical debt that I ever see. People choose an instance type when they deploy something and they never change it. And as a general rule, the newer ones are cheaper and faster. So why would you not do it?
It very much goes into that mindset of cattle versus pets, I believe. And if it's broke, don't fix it. So a lot of people will just say, that's always an instance type. Why change that? Why change our performance? Why risk it? And that just comes to, I think, my opinion, a lack of operational maturity. When you have the ability to kind of spin these up as environments and test them and integrate, integration tests and load tests and all that kind of stuff, then you don't have to even worry about things like instance type changing, because if there is a regression, you'll see it. But that's not a thing that I see a lot of people do.
I think if you're in the position to be worried that changing the instance type might break your application, you want to be the type of company that understands this problem well. So I've never had an issue changing instance types with the applications or the workloads I've had to run on them. It's never really been a big deal.
I've seen it once or twice where there's perhaps a slight degradation in single core performance or something, but it's never really been enough for me to actually dive into why that is. Like, it's always been a couple of percentage points maybe. And the reality is that the instance is that much cheaper that I can absorb that couple of percentage points difference.
So there's a couple of things you're talking about there, because when you were first talking about instance types, I thought you were going to say people chose an instance that was too big or something like that, and then as the needs changed, they didn't go back and resize to or right size that virtual machine or that instance. But you're actually talking about newer generations of instance types coming along and not going back and changing things, right?
Yeah, like I'm talking about when AWS release like a C7, for example, and you stay on a C5 because that's what you deployed your stuff on originally and that's what your Terraform says, when actually a C7 is going to be significantly more performant and a little bit cheaper than the C5 as well.
Are there tools that help you do that? Is there an advisor or something that's going to come along and say, we should do this? Because you think from the cloud's perspective, it's sort of in their interest in a way to get you onto the cheaper instances. I know that they make less money that way, but it also makes you harder to steal from one of the other clouds.
I know that AWS has built-in tooling that will give you a list of instances that are older families and stuff. I know it's in Trusted Advisor, but I can't remember if it's in the free or lower tiers of Trusted Advisor, or if it's something you've got to have an enterprise subscription for.
I know there are tools for this, like in Kubernetes. I know we're talking about cloud particularly, but just FYI, in case you wanted to know, in Kubernetes, there are also tools like that for both like the nodes themselves, things like Carpenter, and also for like the pods themselves, things like Goldilocks.
So what does that actually do? I get it from a cloud perspective of this instance type is running this thing. It's old and crap, updated. But how does that work for Kubernetes?
So at the node level, there are things like Carpenter, which look at like resource utilization, and it'll say, okay, I'm underutilizing on these nodes and I have budget on these other nodes. I'm going to condense down. And then things like Goldilocks will say, given historical trends, right, given some data, that these pods usually need this amount of requests for CPU and for RAM. And then it'll give you that back out. And then what I've done is kind of spat that out into a CI pipeline, which will then go and change the request and limits on pods to just update the resource usage. And that way I kind of always have like a right balance. I have found it to be a little over aggressive, where I have some things that are very bursty but they just are long-lived as pods for when they're needed. So I can reduce that startup time. And it'll say, 90% of the time you need 10 millicores, so go for it. And the problem is that when I actually do need it, I need like 2 whole cores. So it's all about balance.
And I just got the joke in the name, so there you go.
Welcome to the party.
Okay, so we've talked about instance types. What's the next example of tech debt that you guys have seen?
There's probably an equivalent for all cloud providers, but in AWS, I'll speak to specifically. Setting up AWS organizations at the start is a really good idea, because if you live in one single account and then your business gets successful and you need multiple AWS accounts to schedule workloads, setting up an organization, setting up a delegated administrator account to handle billing, doing all of that later on is a humongous technical and legal pain in the neck. You also miss out on a lot of cool, helpful functionality that you might need, like service control policies, which are like IAM permissions, but at the organizational level. Having done this previously, it's quite a lot of pain. So I've actually, even for myself, written a whole set of Terraform modules that like vend everything the way I want it to be vended, should I ever need to spin up another AWS account for a first time for a company. I'll always use them.
And so when you're doing that, are you creating an organization within your AWS account for each, project, department?
This is something that sits above AWS accounts. So you have an AWS account that'll be your effectively your administrative account, and you will have child accounts within that. And you can have then this entire hierarchical structure that kind of represents your organization if you want, but it's basically another level on top of an AWS account that you use to just manage all your other AWS accounts.
Think of it as like Active Directory for AWS accounts. That's a really terrible acronym, but there is a main account which all of your billing and orchestration of things like user credentials goes through, and then you vend sub-accounts and permissions within those accounts to actually deploy your workloads in. I guess it's a little bit more analogous in the Azure world to resource groups and kind of logical permission sets on resource groups.
Shane, that's awesome. Are these Terraform modules you use open source?
They might be. I don't know what repo I've got them on, but they're certainly out of date. But I can have a look and see if I can dust them off. But it's quite helpful because I end up sometimes just trashing everything because I'm like, I don't want to give AWS $1 a month, and then I can just use them to revend everything up.
That's very cool.
I think the other related thing for me there is getting permissions and users right from the beginning and not using things like long-lived credentials. The amount of times I've walked into an environment and I've seen a whole load of like long-lived IAM users with credentials attached to them that just aren't doing anything, haven't had the credentials rotated in 5 years is madness. Use roles, use things like that. Don't use long-lived credentials to access objects in your cloud provider if you can at all help it.
We talk about over-permissioning services, over-provisioning permissions, and then trying to claw them back later on as well. Try avoid that too. Least privilege to avoid your future arguments.
That was going to be along the lines of my example. And I'm curious for you guys, Shane, I think you just had a great example right there about keeping your roles scoped appropriately. Do you guys have any kind of like audits or processes for continuing to make sure that those stay in check?
IAM Access Analyzer is the tool for this on AWS. It will go through all of those IAM principles and it will effectively tell you, like, this person has star on S3, but actually they've only done a put or a get request in the last 90 days. It is an amazing tool.
That's a good call out. And know that GCP and Azure both have similar tools. My question is more to Shane about his personal workflow, whether at personal or at work. Do you guys have something like where you review it quarterly, where you use these tools to kind of make sure permissions are in check? Or is that just a do it as I see it?
Depending on the organization, really, the cadence of these checks will happen. Sometimes it'll be when we start to panic about something and have to reactively deal with it. But ideally, that wouldn't be the case. Sometimes I'll tie this activity to something like disaster recovery. You know, when you maybe have to do something unusual like restore to another AWS account or something else, like it's my time to, like, because people will need certain permissions they may not typically use day to day. I'll use events like that to like give a little review of the permissions I currently have and what they're doing and what else I might need to escalate for them to start their environments from scratch, we'll say. So try to tie it to something regular, I would say. But if you can schedule it often, do.
And I think for me, I've often made use of the resources that I have from the cloud provider. Admittedly, like having been part of a larger customer, pulling in the resources that I get in terms of people from the cloud provider has been really useful. Like SAs and technical account managers will be more than happy to run these kind of reviews for you, spit out some results, and then sit on a call for half an hour and go through them and help with the tracking.
Yeah, actually, you're right. AWS solutions architects were also people who may have given me the nod to say, you should probably review your IAM policies. Actually, they're a good resource to access in general.
Yeah, I've been on both sides of the fence, both getting and giving that advice, and it's usually gratefully received.
Yeah.
So are there some good ways that you can avoid accumulating this kind of tech debt? We've sort of talked topic by topic, but is there a more general way of trying to reduce your tech debt or prevent it?
I think a lot of it is process, right? So things like the AWS well-architected framework are really useful here, where they have whole best practice guidances around how you should architect for security, resiliency, etc. They've got their 5 pillars of what well architected is. Those might not be specific to what we're talking about here, but I think they are general good practices for building architecture that is kind of long lasting and helps to reduce some of this tech debt. So those are definitely worth a look, whether you're an AWS customer or not, I think.
Like Gary said, if you're trying to avoid this, then you really need to put work into tech sustainment and, having ideally maybe about half your time, I would say, dedicated to a year, right? So maybe 50% on tech sustainment and 50% on for development. I think that is really the key, because a lot of times teams will ship it and then never have time dedicated to go back and address things. And things are changing every year. Like Gary said, I think the C5 to C7 example is great. Those things happen very incrementally and they're not a lot of fanfare around them. And so it really takes you being in the know and having time to research that versus hearing about, there's a giant NPM attack because I heard on a podcast and I need to go and adjust my security, right? Taking time to deal with that and working with your managers and your directors to make sure that you are given that time. That's a much tougher conversation, but that's my best advice.
Yeah, I think it's quite easy to say this stuff from an outside perspective, right? Because it's not sexy and it doesn't necessarily help affect the product that your company is building. But equally, if you ignore any of this operational stuff for long enough, you end up with a product that is either costing you way more to run or costing you way more to build, or is just not going to be sustainable in the long term. So I agree. I think it's a really tough sell to higher ups, but having those meaningful conversations and going with data points, and I guess we come back to that again, right? About here is some stuff that we found in our estate that maybe isn't operationally as mature as it should be, is maybe where you should start if you're really struggling to find time to focus on ops versus just building stuff.
And the tech debt interest is compounding every day.
Presumably it's easier in some ways in the public cloud than it is when you're talking about the data center, in that if you do find a few examples of those kind of C5 to C7 changes that are going to save money to the company, at least you can sit there at the end and say, I made these changes and these are the dollars that I've seen out of it, which is a bit harder if you're talking about, resource utilization on physical boxes.
Well, 3 clicks to move from a C5 to a C7 is much easier than getting a PO signed off with HP to buy some new tin, right? So, yeah, I think some of this stuff I would agree, yes. Equally, there is some stuff that is also doable in an on-prem environment. Permissions audits. Okay, the tooling might be a little bit different than it is in the cloud world, but it still exists, and it's absolutely something that you should be building into regular operational review cadences.
I don't know of any tools to kind of do this kind of resource management and optimization on-prem.
Well, it's going to be reliant on whatever tooling you've got in place. Like for my on-prem environment at home, I make quite heavy use of NetData. That has some quite nice tooling in where it will go and look back at the last 30, 60, 90 days, 6 months, 1 year, and give you an idea of where it thinks your projected resource utilization is and where it's going to help you plan a bit more of that stuff. But again, it's going to depend really heavily on what the stack is that you've invested in.
We touched on it a little bit before, but have people found those cloud advisors to be useful for this kind of auditing process?
Good for the low-hanging fruit. Like, they'll always give recommendations. It sort of seems sensible. It's the basics. You'll still probably get wrong, but definitely you'll miss something and it'll highlight that. So it's been pretty good for that. But for like things that are particularly nuanced, like there may be optimizations to the way you distribute your workloads, like across compute. Oh, this is very bursty. Maybe it should be in Lambda or running as a container. It doesn't tend to give me those sorts of recommendations. It's more your box is too small.
Yeah, I think it's a really good baseline, but that's sort of why I pointed out that if you've got the resources on the cloud provider side to really dive into this information, then they are absolutely the people to be talking to, because they will, in their head, be comparing your environment to 5 or 6 other customer environments that they know about, and maybe they've seen a similar pattern before where a certain architectural pattern or change has helped, or perhaps they could introduce you to someone with a service team within that cloud provider who can help out with some architectural best practice. So, yeah, there's not a one-size-fits-all approach to a lot of this stuff, and the advisors in the clouds take you so far, but the bottom line is that someone who knows and understands your environment or environments like it is going to take you a lot further than just looking at the output from some tool will.
So we've talked about regular auditing, and we've talked about process or investing a certain amount every year and going back and looking over your estate. Are there more architectural ways that we should point out that make this sort of thing easier? I mean, one of the ones that jumps to my mind is the kind of infrastructure as code style stuff we were talking about before, and maybe separating things out a bit more. But are there things like that that people should be doing in order to make this easier?
Not doing ClickOps is definitely a great shout. Yeah, that's sort of like bread and butter to me, but that may not be the case for everyone. Other things like labeling, actually, really boring, but like getting labeling right at the start so you actually know what the hell you're running is really sensible, I think. It's things like that where it's quite cheap to do, just make a decision. Even if it's a wrong decision, it's better than no decision, and then iterate as you learn.
Yeah, that's a good point I hadn't thought of. I remember doing something with the Azure policy stuff to make sure that you always had tags associated with resources in a way that meant that you could then go back and run the cost analytics and figure out, which department and whether it was dev and test or prod. That kind of stuff, I think, can be quite interesting in terms of making sure you're set up, not on day one, but when you come to wanting to do that analysis later, that you've got the right data.
I think those tags are also really useful to help track this stuff back to metrics that business people higher up than you might understand. So if you could learn what the business measures the cost of a product in and start to speak that language, it suddenly really shifts the conversation between, we're spending too much on this service to, we know your target cost of delivering this product is $5 per user per month, and we can currently see that it's $8 per user per month. Those kind of conversations are really useful to get buy-in to actually spend time on these things. So, yeah, I think I agree that tagging is super important, not only for tracking what you're doing, but also just enabling you to track it in a way that the business will understand.
For a lowly example, when you're handed an EC2 instance that's been running for 3 years, has no labels, and has a randomly generated ID, and you're like, okay, I guess I'll try find a way to shell onto this and figure out what the hell this is doing. Like, labels are very, very helpful in this scenario. So yeah, please label.
Just add a label right there. Tech debt. Next.
Yeah. Do not turn off.
Are there any examples of tools that help you do tagging and cost analytics across clouds? I'm just thinking that everything we've talked about has been very cloud specific.
There are a couple tools, but how do I say this nicely? It's not going to be up to you to choose them. That is much more like a director choice, where they choose tools like Cloudability, who can do this kind of like multi-cloud spend setup. And then aggregating that with on-prem and, cost benefit analysis. That's a whole entire other set of data science.
Yeah, I mean, there's, like you said, there's stuff like Vantage. There's stuff like, I think Datadog has got some of this stuff built in as well. I know that AWS have their cloud intelligence dashboards that you can just deploy inside QuickSight, which may be a little bit more in your control to do. And then they pull in the cost and usage reporting files from both AWS and Azure. So they're quite a useful way to concatenate that stuff in one place if you've maybe not got the budget to go out and buy another tool.
We've talked quite a bit about effectively getting the most out of your cloud or optimizing your cloud usage and spend, that kind of thing. What are some other examples of tech debt that you've come across?
Understanding the component parts that build up your application and life cycling those appropriately.
What do you mean, Gary?
So I think what I'm thinking about here is, say you've got some PHP code that's running on an Apache server. You've got a Lambda function that is running a Node.js front end, and then you've got a database that's running Postgres or something in the back end. I've just described the weirdest, most inappropriate stack ever for running an application, but you get my point.
Sounds amazing.
So what I mean here is understanding what all makes up that application, right? So is there a specific version of PHP or Apache that you're using? What would it take, or what tech debt are you bringing in as you're building that code that would stop you from upgrading to a future version of PHP? Your Node.js front end that's sitting in Lambda. What version of Node.js are you using? What is the AWS lifecycle for that version of Node.js? Understand what happens when that version of Node.js comes end of life in terms of deploying and updating that Lambda function. What is the database you're running? When does that go end of life? How are you planning for and executing the upgrade for that? Are you using blue-green deployments? Are you just switching out the database and stopping the application? All of these things I think are super common that people just forget about because they go, oh, I'm using Lambda, the cloud provider will worry about that for me. Or I'm using a managed database, the cloud provider will worry about that for me. And the reality is that, yes, they're running the infrastructure, but you still need to make sure that the code or the things that you're depending on that infrastructure for can support newer versions of software that might be running on it.
I am very grateful, I think, for the cloud providers doing this as well. Like Lambda being like deprecating versions, old versions of languages is really helpful to force engineers. And so your hands are tied as a platform engineer in the middle being like, sorry, folks, you're going to have to do the right thing and upgrade because otherwise these Lambdas are going to break. Same with MySQL, I think I remember going through a particularly painful migration from 5.7 to 7 something, which the cloud provider forced because we were on AWS. So yes, these things do introduce pain. You do need to notify people early and be aware of your entire real estate, what you're running and what the risks are for that going out of date, and then banging the drum really to get application teams to follow suit.
Yeah, I mean, the slightly scary bit with some of that now, particularly the databases on AWS, is that AWS will just start charging you for extended support. So one day your bill is just going to increase by $3,000 and you're going to be left wondering why. So understanding what those component parts are and the life cycle around them, I think is super important.
Generally, I think dependencies and pulling random stuff from random places is something I come across a lot, that people don't really think about where they've pulled all the bits of what they're using from, and then have a support problem very quickly or a security maintenance problem very quickly.
Oh, yeah.
Because they haven't thought through, well, the place I got this from, some random GitHub site or some random container off Docker Hub or whatever. They haven't thought what the security lifecycle of that is until someone's come along later and said, well, where are the updates?
Aaron, it's 2025. Now the new source of random dependencies is AI. Just saying, hey, bring in this dependency and it's going to do everything for you. And never mind that it has 300 other dependencies. But that's actually a very good point. And that's where, dev meets ops, where now you have to start caring about what dependencies devs are pulling into their packages and how do you manage those and how do you keep them up to date. And that's why one of the first things I did at my new company was create a platform for Renovate that would just auto onboard all the repos if you give it a tag on your repository. And that has saved us so much time. And if you have really good CI, then you can just use auto merge. And then it's not only saving you time, but now also money. Because now it's not time you're spending in development. Now you're just automatically getting these upgrades for free. And especially if you have stuff like minor patch versions that have the security implications. That's a lot of time that your platform team has just saved you.
That's a nice problem to have, like having diligent engineers merge, renovate pull requests. That's great. I will end up thinking about how can we put some sort of proxy between ourselves and Ubuntu's repos, because they're going to stop serving PHP 5.6 or something. It's usually things like where you decouple yourself from the horrendous dependencies you have around me is what I would immediately go to.
To be fair, I think PHP 5.6 needs to go. I think it's about time. Good job, Ubuntu.
No, it's in its heyday. It's ready.
Oh my God.
I think really, though, to solve the whole tech debt issue, it's just to build hugely unsuccessful products that go nowhere, or you're just going to have to manage the tech debt. No matter what happens at the start of your company, you're going to make the wrong assumptions. You're going to make quick decisions to get product market fit quickly or whatever, and you're going to have to pay the tech debt at some point. So it's probably why we're talking more about process and managing it than how are we going to solve it, because you can't solve it.
You can't solve it.
So it's just minimizing the pain, trying to do the right thing.
Shane, did you just describe product as cattle? We should coin that. That's great.
I like that.
Product as cattle. Yeah. That's good.
Feels like a business book right there.
Oh, I'm going to register this domain. Conference coming in 2026.
This may sound like a dumb question, but inevitably, 10 years down the road, the smart engineer who developed or set up the infrastructure has no doubt moved on to brighter futures. And you're left with something that you've got to clean up after. Is there, sensible process around explaining what stuff was for and what's included in there, so that when someone does have to come in and take over some horrendous thing, that they understand a bit better why it's there and what it's supposed to be doing?
You mean documentation?
Yeah, but associated with like resources and applications and things like that.
You mean documentation?
I guess, yeah.
For me and companies I worked at, that's just a standard process of everyday engineering. Document everything you can while you're doing it, because if you wait till the end, you're going to forget it, you're going to miss context, and then making sure that proceeds on, that someone continually updates it as people go through it and make updates and dependencies change and all that stuff, right? That way, that context isn't lost, because inevitably at some point it will be. And it's going to make the 10-year engineer right down the line life much harder.
I think that's just good advice for any set of technical stuff that you ever set up. Like, I'm going through the pain right now of going and redocumenting a bunch of sound production equipment that someone set up 5 years ago, and they've been gone for 3 years and everything is a mess. None of their documentation made sense because a bunch of engineers just started looking after it and no one documented the why of why anything happened. So I think, just document as much as you can. There can never be too much documentation, unless, of course, it all gets abandoned, in which case it's probably useless.
To be honest, documenting is something I started doing with my own infrastructure about 10 years ago, because I was so sick of trying to figure out how I'd done the same thing, when I rolled around 2-3 years later. And so now, even when I'm busy setting up my Jellyfin server or my, Nebula or whatever, if it's not infrastructure as code, then it's sitting there in some Joplin notebook or something.
Well, even if it is infrastructure as code, I'm a real fan of just putting some inline comments in there to explain why I chose this list of packages in an Ansible file, for example. Like, what I need to do. Are there any things that, for example, after I've installed Nginx and set up a bunch of websites, do I need to tell Certbot to go and run to deploy some certificates? Like, even if it's self-documenting, I still leave myself little notes and breadcrumbs around, because I'll come back to that when the next Ubuntu LTS releases and think, why the hell isn't this working? What have I missed? And then I go and check the code, and lo and behold, there's a note I left myself 2 years ago.
I'll go so far as to update the bash or C or ZSH or C file on servers to remind me what the hell the bloody thing is doing and which files I'm supposed to. If I'm shelling on here, I need to do one of 4 things probably: kill this container, or I don't know, remove this cache file. So just write them in a file. It's right there in front of you. Bob's your uncle, you're done.
I'm not sure if that's genius or insane. Oh my God.
Well, that's probably a good place to wrap things up. Before we do, just a quick thank you to our PayPal supporters and patrons. If you have any questions or feedback, you can send those to us at show@hybridcloudshow.com. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.